So, secants, tangents, and angle measures. Secant is a line that intersects the circle in exactly 2 points. Okay. Tangent, how many times did you intersect the circle?
Once.
1 time. Okay, so secant we intersect twice, tangent we intersect once. That's the difference between them. First theorem. If 2 secants intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the 2 arcs intercepted by the angle. Whoop, let's see if I can get circle spelt correctly. There we go. So if 2 secants intersect in the interior of a circle, then the measure of the angle formed is 1/2 the measure of the arcs intercepted by its angle and its vertical angles. So the key here is if we are interior of the circle, we're going to add the 2 arcs that it intersects and divide it by 2. So if I want to find angle 1, I'm going to look at angle 1. I see that one of the arcs that it's being intersected is PR. The other one is QS. So I'm going to add those 2 arcs together and divide by 2, or take half of it. Okay. So for example, let's say I give you from P to R is 70 degrees, and from Q to S is 30 degrees. And I want to find angle 1. What would I do with the 70 and the 30? Yep, so I would start by adding them. So 70 plus 30 is 100, and half of 100 is 50. So angle 1 would be 50 degrees.
Why can't you just do the thing that we did last, like divide it in half?
Okay, we can't divide it in half because this angle is not on the circle. It's not inscribed. See, it's on the inside of it. Okay? All right, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. Someone needs to go through and spell check these, I think, beforehand. There we go. No, your papers are fine. I have to type it again in here, and there isn't spell check in this program. So I just type as fast as I can, and I don't necessarily read it again. All right, so here we have a secant and a tangent, and they are intersecting at the point of tangency. So they intersect at the point of tangency. So where would that happen? Would it happen on the circle, in the circle, outside of the circle? Point of tangency would be on the circle. Okay, so this is happening on the circle. So then we want to find the measure of its intercepted arc. So here, we are intersecting on the circle. Now, since we intersect on the circle, we can just take half of the arc that it intersects. So if I know the arc TV, to get that angle, YTV, I would just take half of it. Okay, over here, I know the arc TUV, to get that angle, I would just take half of it. Because we're on the circle, so we can just take half. So for example, if I told you that the measure of arc TUV is 300 degrees. Yeah. Well, yeah, TV would be 60 degrees. That would be for sure. But what would be the angle XTV then? It'd be 150. And the angle YTV would be YTV, if this arc is 60, YTV would be 30. Okay? So when we're on the circle, we can still divide the arc by 2, which is what we were doing before. Okay? In the circle, though, we have to add the two intercepted arcs and divide by 2. All right, and then there's another type that we can see. These are all intersecting where? Where does it look like? Outside of the circle, okay? So if two secants, a secant and a tangent, or two tangents, they intersect in the exterior of the circle, the measure of the angle formed is half of the positive differences of the measure of the intercepted arcs. So what that means is if we are intersecting outside of the circle, we're going to subtract the 2 arcs and divide by 2. Okay? If you subtract them in the wrong way and get a negative number, that's just fine. Turn it positive and then divide by 2. So these all are intersecting outside, so for all of these you end up subtracting. It doesn't matter if it's 2 secants, a tangent and a secant, or 2 tangents. If you intersect outside, you subtract the 2 arcs. So, for example, here angle P. If you know arc BE is, I don't know, let's call that one 90 degrees. Let's call AD 10 degrees. How would you find angle P? Yeah, you do 90 minus 10 is 80, and then half of 80 is 40, so angle P would be 40. Okay. Then you're going to do the same idea for this next one. So let's say I told you GKJ, that arc was 160. GH here was, let's make GH 40. How would you get Q? Yeah, 120 divided by 2, because you'd have to do 160 minus 40, which is 120, divided by 2 is 60. Okay, this last one is 2 tangents. So let's say I tell you the measure of arc MN is 100 degrees. I don't need to tell you anything else. Why not? Right, this whole circle would be 360. So if this portion is 100, what's the other portion? 260. So then to get angle R, what would you do? Yep, 260 minus 100 and divide that by 2. So 260 minus 100 is 160, and half of 160 gives you 80. Okay? So that's what we need to keep in mind. So if we intersect in the circle, what do we do with the 2 arcs? Inside of the circle, we add, divide by 2. On the circle, just divide by 2. And outside of the circle, subtract, divide by 2. Okay, so inside we add, on, just divide by 2. Outside we subtract. So let's try some examples. So here's our first example. We want to find the measure of angle 1. How would I find that? Add them and divide by 2. Why would I add them and divide by 2? Yep, we are intersecting inside of the circle, so we'll take 52 plus 40 and divide by 2, or take half of that. So it's 52 plus 40, 92. So half of 92 is 46 degrees. So angle 1 here is 46 degrees. Okay, second one, we want to find the measure of angle 3. So angle 3 is on the circle, so what would we do? Just divide by 2, so we would take half of 220. 110 degrees. Is that okay? Okay, measure of angle 2. This is on the circle, so what would you do with this one? Yeah, just do half of 92, or 92 divided by 2, so 46 degrees. Angle 4. Well, where's angle 4 located? On the circle, But do we know that arc? Can we find it? How can we find it? Okay, so notice that this circle, the line here, this is the diameter. So that total should be 180, and we know just this portion is 120, so what's this other? So this portion is 60, and since 4 is on the circle, yep, 60 divided by 2, or half of 60 is 30. Is that okay? All right, how are we going to find angle 5 for the next one? Okay, so if we add these two together and divide by 2, does that actually give us 5? No, but we can find 5 then, right? So let's start with that. So 130 plus 90, and we're going to divide that by 2 or take half of it. So what's 130 plus 90? 220, so half of 220 is 110. So this angle here is 110. That's not angle 5. How would we get angle 5? Yep, subtracted from 180. So what is that then? 70. So angle 5 is 70 degrees. Sound okay? All right, number 6. How would I find angle 6? It's on the circle, so I have to divide by 2, but do I know what the angle arc is? Right, I can find it. The whole circle should be 360. I know just this part is 160. So what would be the remaining part? 200, yep. So then what would angle 6 be? 100 degrees, because we took half of 200, or 200 divided by 2. Okay, next one. What would I do to find this one? Subtract and divide by 2. Oh, no. Oh, yep, 40. So we do 80 minus 40. Take half of that. So half of 40 ends up giving you 20 degrees. So angle 1 is 20 degrees. Okay, what would we do for number 8? Same idea. Okay, so how are you going to set it up? 160 minus 80 and take half of that. So half of 80 is 40. So angle 2 is 40. Okay, these were all fairly straightforward so far, right? Okay, so sometimes we're going to have variables in there, or we're going to have to create some variables in there. Oh, number 3 is not as difficult as I wanted 3 to be, or 9. That's okay. All right, so we want to find angle 3. How can we find angle 3 here? Okay, so subtract 220 from 360 to get this angle, and what will that arc be then? 140. Okay, so then how do I find angle 3? Yep, 220. And we take half of that, so what's half of that? What's 220 minus 140? 80, so half of 80 is 40 degrees. For some reason, I thought I had more than just this one with x, but that's okay. We can do one with x. So how would I find x here? No, we wouldn't add 70 and 20. How do they intersect? In, on, or out? Out. So that means what do you have to do with the two arcs? Subtract them. So subtract your two arcs. What do you do once when you subtract your two arcs? You do what with it? Divide by 2 or take half of it, and that should then equal, what's your angle? 20. So you just have to set up the equation with the x in there and then solve for x.
So just be 35 minus...
You could do 35 minus half x. What's another way that you could get rid of this half, though? Or you could times both sides by 2, and then you would have 70 minus x is equal to, well, what's 20 times 2? 40. So what would we do?
minus 70.
Minus 70. So we have negative x is equal to negative 30. So x is equal to 30. Is that okay? I feel like there's quite a few more with variables on your assignment than just one. But you just have to think about how it should be set up and just put your variable right in there. So for tomorrow, page 565, 12 to 30. Yes, you may.